Let's talk about the properties of the transpose of a matrix. This is one of the property of the transpose on the topic on matrices under linear algebra. It tells us that the transpose of the transpose of A is just the matrix A in itself. So we're going to show that this is true, but of course, we are going to start by coming up. Okay, let's have this proof here. We're going to let matrix A into a certain representation that is true for all types of matrices. It's not just for 2 by 2, 3 by 3, 2 by 3, so on and so forth. So we're going to let here A as an m by n. So we have A is an m by n matrix. In short, it has m number of rows and n number of columns. So with that, we can actually come up here with a certain representation. Hopefully you could bear with me. We can use here the representation for our matrix A. We have here these components A11, A12, A13, dot until A number of columns is n. So you have n A1n. Okay. Then you will have here A21, A31 until your mth row. So since we are doing this so that it is true, this property transpose is true for all, because transpose can always be computed for any type of matrices. So we'll have here A22, A23, A2n. We have A32, A33, A3n until AM2, AM3 until AM and n. So we have now a representation for our matrix A. Now, let's look into the first form. So we have here the transpose of A. The transpose of matrix A is where we interchange the components or entries from rows into columns. In short, if our A is originally an m by n matrix, its transpose would be n by m matrix, where the number of rows earlier becomes the number of columns now, and the number of columns earlier becomes the number of rows. In the form of representation, we simply just put, going back to our A here, this was the entries of our first row. This will now be the entries of our first column. Okay, so A11 is still here, and then the A12 will be part of the same column. A13 will be part of the same column until A1n. So these entries becomes an entry of the first column. Similarly, the entries of our original column will be, first column will become the first row. So we will have here A21, A31 until AM1. This will be true for all the entries. Supposedly, if we have an m by m or n by n matrix, the transpose will be interchanging all the components of the upper and the lower triangular portions. But since this is not a square matrix, it is an m by n matrix, so we're going to have the same process. So this second row rather will become your second column, A22, A23 rather, A23 until A2n. This will become a new column, A32, A33 until A3n. This last row will become your last column, AM3 and AMn. This is still the transpose of A. Now, we are going to show that the transpose of this is A itself. Okay? Analytically, it is closer to that as we look into this, since the transpose of T is now an n by m matrix. Its transpose, or the transpose of the transpose, will return into an m by n matrix, of course. But component-wise, we're going to show it here. So we have here the transpose of the transpose. Okay, transpose of the transpose. So looking into this, this will be our new reference. We're going to take the transpose of this. So you have the transpose of the transpose. Looking into the perspective, this row of the A transpose will become its column here. So we have A11, A21, A31, AM1. Okay? This row will become the second column. A12, A22, A32, AM2. Next, A13, A23, A33, AM3. And the last row will be its last column, A1N, A2N, A3N, AMN. By the way, that's the same. So when you close this one here, this is now the transpose of the transpose of A. But what is this exactly? Looking into this, I could compare it with this original A11, A12, A13 to A1N. You have here A11, A12, A13 to A1N. Going to the first column, A11, A21, A31 to AM1. You have A11, A21, A31 to AM1. So basically, this last matrix is just equal to our matrix A. Cutting this short, we have now shown that the transpose of the transpose of A is matrix A in itself. This is the first property of transpose, which we're able to show here analytically and of course using this deductively. So this is how we show this property of the transpose. This is Properties, Laws, and Theorems. Please subscribe now.